Hello everyone, welcome to my channel. Let's solve this question together. Okay, look at this beautiful question on the board. Okay, now they are giving a beautiful diagram. We are asked to find what? Find the current through 3 ohms for resistor using what? Superposition theory. Wow, this is beautiful, right? Now we heard about superposition. Look at superposition theory. You know, it's very simple. Okay, now superposition theory states that in any circuit that there is more than what? More than one source. Look at, yes, one source, yes, second, yes, another source. Where is more than one source? Before you can analyze the circuit, that's what the law states. This state that before you can analyze that circuit, that means we have to evaluate one of the source. This is one of the source. This is one of the source. So we have to evaluate. To evaluate means to remove or to make it what? Short-circuited. To make it short-circuit, right? And solve and do what? And work on the first source. Okay. So what you are going to do in this circuit, we are going to evaluate one of the source to make it well sub-circuited. Okay. So very simple and solve for what you are looking for. Maybe the current or the total resistance. Very simple. Okay. Now let's make this circuit sub-circuited. So let's draw this circuit back. So this is the circuit. Okay. Make it very sharp. I want to make it sub-circuit. Circuit. Now this was 3 ohms. This was 6 ohms. This was 5 ohms. This was 20 plus minus. Well, this was 20 volts, right? Yeah, 20 volts. Okay, I'm done, right? All right. Good. Now this is what short circuit. Okay. Now you can see that I remove this source. I'm working with this source now. That's the properties of superposition theory. It said that in any circuit where there's more sources, what you have to do before you can analyze that circuit, evaluate one of the source. Okay, at a time, evaluate one of the source. So what you have to do to evaluate means to remove this first. So that's why I make this source circuit. So make this source simply means there's no source here. There's no source producing any current here, any flow of electrons. There's no source. It's only this source you are seeing that's providing source current to this circuit. You can see. So let's work on this source. Okay, very simple. Okay, now let me also draw your mind to Ohm's law. You know, Ohm's law states that the total amount of current that flows in a metallic conductor is directly proportional to total voltage and inversely direct proportional to resistance, but provided the temperature remain what? Constant. It means that our I, total I, is equals to V over what? Total R, which is our total resistance. But in this circuit, we have our total current and total voltage, which is 20 volts, right? But we don't know our total resistance, which is equivalent, because also equivalent resistance, right? But we don't know how we're going to do. So I can have the total resistance in this, so I can have a total current in this circuit. Remember what we are asked to find? We are asked to find what? Find the current through 3 ohms resistor using what? Superposition theory. And I say earlier, don't forget that superposition theory have to deal with or state that in any circuit that contain what? More than one source. Okay, what you have to do before you can analyze that circuit, what you have to do is to evaluate one, okay, at a time. So that's what you are doing. So evaluate one at a time simply means what to make one sub-circuit. This sub-circuit means that there's no source here. It's only this source you are seeing there's working on in this circuit. There's no source here. You can see space is empty. Beautiful. Now let's find our total resistance, right? That means TR. That means total resistance is equals to. Now remember that our current flows this direction. Don't forget, okay? Our current flows this direction, right? Now you can see that this and this are what? They are series, but this is in parallel. It means that if here is arrow 1 and here is arrow 2 and here is arrow 3, it means that arrow 3 is parallel to arrow 2. You can see they are parallel. You can see, because if you put this thing in this form, you can see that arrow 3 is parallel to arrow 2. You can see, but they are parallel to arrow 2 in series to what? Arrow 1. You can see. So it means that arrow 1 is in series plus what? Plus this and this are in parallel. Arrow 2 times what? Times arrow 3 divided by arrow 2 plus arrow what? Arrow 3. You can see. You can see this arrow 1 is 5 ohms. Arrow 2 is what? 6 ohms. Arrow 3 is what? 3 ohms. Beautiful. This is beautiful, right? Now that means our total what? Resistance, you can call it what? Equivalent resistance is equals to 5, which is what? Arrow 1 plus into what is arrow 2? Arrow 2 is what? 6 multiplied by what? Multiplied by 3 divided by what? 6 plus what? 3. Wow, this is pocket genius, right? That means our total resistance is equals to 5 plus what? 3 times 6 times 3 give us 18. 6 plus 3 give us 9. So 18 divided by 9 give us 2. So it means our total resistance, okay, is equals to 5 plus what? Plus 2. Because 18 divided by 9 is 2. So 5 plus 2 give us what? This is equals to what? 7 or 7 ohms. Wow. This is our total resistance in this circuit. Beautiful. Now, for us to know our total what? Current. It means that total current is equals to what? Look at 20 volts. It becomes what? 20 divided by 7. Let's see 20 divided by 7. 20 divided by 7 give us what? 20 divided by 7 going to give us what? That means our total current is equals to 2.8. Let's put in 3 decimal place. 2.857 amps. This is our total current in this circuit. Wow, this is pocket genius. Amazing. I love this. Wow. Now we are getting the total current in this circuit. Okay. Now, also, have you heard about current division rule? Now, what does current division rule do? Current division rule enable us to find current in each of the what? In each of the branch of the what? Resistor. Now, current division rule say help us to find the current that flow in this resistor. Okay, that's the help of current division. Remember, we have voltage division divider rule, and current division rule simply help us a lot because it help us to do what? To know the amount of current that flow in each of the what? Resistor. So for I1, let's see the current that flow in I1, because if we know the current that flow in I1 and know the current that flow in I2, we can know the current that go into I3, because we have to find the current that flow into what? Look at, find the current flow 3 ohms resistor, that flow through 3 ohm resistor. That means if you can know the current that flow here and know the current that flow, you can know the current that is entering here, because this is going this direction and this is going this direction and this is coming this direction. So if you can know the current that is in this resistor and know the current that is passing through this resistor, we can know the current that is entering the resistor. I1 is the current that flow in resistor 5, I2 is the current that flow in resistor 6, and I3 is the current we are looking for. Okay, we are looking for this current. That means if you can know the current that flow here and know the current that flow here, we can know the current that is entering here. Okay, that's the current we are looking for. So for us to have this current that is flowing here, that means we have to say that I1 is equals to total current, okay, then multiply by what? Multiply by resistor what? This is resistor 1, this is resistor 2, this is what? Resistor 3, right? So multiply what? This is resistor 2 divided by the sum what? The sum of the what? Resistor 1 plus what? Resistor 2, because they're in parallel, right? Now that means I1 is equals to, what is our total current? Our total current is 2.85 what? 2.857 into resistor 2 is what? Is 6 ohms. So this becomes 6 divided by what? 6 plus what? 3, right? So it means that I1 is equals to 2.857 into, to give us 6 over what? 6 over 9, right? 6 over 9, because 6 plus 3 is 9. That means our I1 is equals to 2.857 into, now what can go 3 into 6 how many times? 2 times. 3 into 9 is 3 times. So you have here as what? 2 over what? 2 over 3. Now let's multiply everything here and know about current that flowing I1. That means 2.857 multiplied by 2. It give us what? It give us, that means our I1, which is the current that flow in this resistor 5, will be equals to 5.714 divided by what? 3. Let's divide it, divided by what? 3. So we have what? Our I1 is equals to what? 1.90 what? By to opposite to the nearest 3, to whole number to 3 decimal place, become what? 5 what? Amps. Now this is the current. This is the current that flow here. This current you're seeing is the current that flow here. Remember, this is in this direction, right? Now this is the current that flow here. Now for us to know the current that flow here, what you have to do is to bring back this source that is here and do what? Evaluate this other source. Okay? Can you see how simple and interesting it is? That's why I say if you understand superposition theory, look at superposition theory. It means that in any circuit where there is more than one source, what you have to do before you can analyze that circuit, what you have to do, make one sub-circuit test. That's why you evaluate one circuit. Okay? Evaluate one circuit at a time. Okay, now you can see we are evaluating this circuit. So what we are going to do, we have known that our I1 is what? Our I1 is equals to what? Equals to 1.90 what? 5 what? Amps. And we know that our total current is equals to what? 2.857 0.57 odd amps, and our total resistance is equals to what? Is equals to what? 7 what? Ohms. Okay. Now we can remove everything here and solve for the other one source. You let's consider the other source. So we can remove everything here, right? Let's remove everything here. Very simple, right? All right. Okay. Now let's keep this safe. We are going to work with this. Now let's consider the second source. We are done with this source, right? Let's consider it. So let's make here sub circuit. Short circuit, right? It was about 3 ohms. It's about 6 ohms. It's about 5 ohms. This is about 40 watt, 40 volt. This is about E2. This is our second source. You can see very simple. That's what superposition theory. You can see how simple it is. Very simple, right? Now, from here, let's know our total current, because first of all, look for our total current. Let's know our total current. Our total current will be equals to V over our total resistance. But we don't know total resistance in this what? In this is second source, right? Now, what are we going to do to know our total resistance? That means our total resistance will be equals to. Now, let's observe carefully. You can see that. You can see that you can see that 3 ohms, which is this 3 ohms is parallel to this in series with this. So it means that this will become what? 6 plus what into 5. 5 times what? 5 times 3 divided by 5 plus what? Plus 3, right? So that means total resistance, we can call equivalent resistance equals to 6 plus what into 5 times 3 going to give us 15 divided by what? Divided by 8, right? Divided by 8. So now see that total resistance is equals to 6 plus what? 15 over what? 8. Denominator here is 1. Let's take our LCM. That means total resistance is equals to, our LCM is what? Our LCM is 8. Now 8 divided by 1 is going to give us 8. 8 times 6 is going to give us what? 40 what? 48. Okay, plus 8 into 8 is 1. So 1 times 15 is going to give us 15. That means our total resistance is equals to plus what? Plus 15 going to give us what? 60 what? 63 divided by 8. Let's divide 63 by 8. You're going to have what? You're going to have our total resistance in this circuit is equals to what? 7.8 watts, 875 ohms. Wow, this is amazing, right? Now this is beautiful. Now we're going to our total what? Our total was resistance. Let's look for our total current. That means total current, which is T subscript T, I subscript T is equals to V over what? Arrow subscript what? T. This will be equals to our total voltage is what? 40 ohms. So this is what? 40 divided by total resistance is what? 7.875. 7.875, right? So let's divide it. 40 divided by 7.8575. Let's see. So that means our total current is equals to 5.07 what? 79 amps. Wow, this is amazing, right? Don't forget that this is I1, this is our I2, and this is our I3. But we are looking for the current that is flowing this. But we are knowing the current that is I1. Current that is I1 is 1.905 amps. But we don't know the current that is in I2. Remember that this current is going this way. It's going this way, right? Now, if you can know the current that is going this direction, and know the current that is going this direction, you know the current that is entering this here. You see? So we are getting the current that is going, we are getting the current that is flowing this resistor. But we don't know the current that is flowing this other resistor. Let's find the current that is flowing this resistor. That's why you have to draw your mind to what? To current division what rule. Very simple, right? Now let's remove this from here and solve for our this. So I can remove this from here, right? Let me remove this from here quickly. Alright. Now that means it will be what? I2 is equals to our total what? Total current. Total current, which is just into. Now let's look for the current that flowing I2. Remember we are getting the current that flowing I1. The current that flowing I1 is 1.905 amps. Let's look for the current that flowing I2. Before we can know the current that is entering what? I3. Okay. Now, by what? By division rule. Okay, current division rule. That means I2 will be equals to total current into what? Into 5 divided by what? 5 plus what? 5 plus 3. Okay, that means this is total current. Sorry. Now our I2, the current that flowing I2 be equals to total current is what? Is 5.07 into 5 divided by what? 8, right? Fine. Because 5 plus 3 is 8. So that means I2 is equals to 5.079 into. Now let's multiply this times what? Times 5 divided by what? Divided by what? 8. Let's do that quickly. Let's see. 5.079 times 5 is going to give us what? This will be equals to 25.395 divided by what? 8. So let's divide it by 8. Well, for this will be equals to what? 3.174 amps. Now that means the current that flowing I2 is what? 3.174 amps. If you have known the current that flow here, remember this is flowing this direction, right? If you know the current that is flowing here, and also know the current that is flowing here, flowing to here, so that means this is a loop. Okay, we can know the current that is entering here. That means this plus this will give us the current that is going here, and this minus this will give us the current that is going here, and this minus this will give us the current that is going here. So now we can find the current in our what? Resistor what? 3. So let me remove this from here, please. Let me remove this from here. Now we can find the current. That means I1 plus what? I2 is equals to what? I3. Now this plus this will give us the current that is going here. So that means I1 is what? I1 is 1.905 plus our I2 is what? 3.174 equals to what? Total what? Current. Sorry, our total current in resistor. Our current in resistor 3, which is I3. So let's sum it together. 1.905 plus 3.174 3.1774, right? So this is what this will give us 5.079 equals to what? 3 what? I3. It implies that I3 is equals to 5.007 amps. Wow, this is amazing, right? This is amazing. Now we are getting because we are asked to find the current through 3 ohms resistor using superposition theory. And I've told you earlier that when you heard about superposition theory, it's very simple. Now superposition theory states that in any circuit where there's more sources, what you have to do before you can analyze that circuit, evaluate one of the circuit. What did I mean by evaluate? Make one sub-circuit. Okay, now what you have to do to make one sub-circuit, remember we sub-circuit this and solve for the current here, also solve for the total resistance, which is also called equivalent resistance. Okay, and also do what? And also sub-circuit here and also work on this. Okay, so that means our current that is flowing I3 is equals to what? 5.079 amps. That is the current. Now if this is true, that means the current that is going here minus the current that is here will give us the current that is going this direction. The current that is here minus the current here will give us the current that is going this direction. And the current that is here minus the current here will give us the current that is going this direction. Very simple. So thank you so much for watching. Please, if you find it very interesting, don't hesitate. Do it to like, comment, and share it to your loved ones so that others will learn from it. Please, if you're not subscribed, consider to subscribe to this channel so that anytime another exciting video like this, you will also be notified. Okay? So thank you so much, and God bless you. Bye-bye.